Alright guys, so in this video we are continuing to look into evaluating integrals by u substitution. Alright, so let's take a look at this example right here. X squared times the root of 5 plus 2x cubed. So at some point you might be starting to ask yourself, well, I just don't get it. How are you choosing these u's as your u for the u substitution? Well, it all really just comes down to is putting it in your favor. Alright, so looking at this example, I know personally that 5 plus 2x cubed is going to be a good use for a u in this case. Why? Well, the reason why is because, remember, you're going to have to take the derivative of u at some point. And when you take the derivative of u, which would be 5 plus 2x cubed in this time, you'd end up bringing that 3 down, multiplying it, you'll get a squared term, an x squared term. And to the left of my root, I already have an x squared term. That's a good thing, because you want to be able to replace that x squared dx term with your du. So, let's take a look at exactly how it's going to work. Let's make u equal 5 plus 2x cubed. Du in this case will equal 6x squared dx. Alright, now I'm going to go ahead and rewrite the original integral to kind of put it in a more favorable position. So I'm going to rewrite it as 5 plus 2x cubed to the 1/2 power times x squared dx. Okay? The reason why I want to write that like that is because let's take a look here. Up top we have x squared times dx, and now down below we have x squared times dx. The only difference is that constant of 6, or that coefficient in this case of 6. But remember, I can rewrite this as 1/6 times the integral of 5 plus 2x cubed to the 1/2 power times 6x squared dx. All I did was 6 times 1/6. That is 1. That doesn't really change value anywhere. I'm doing this so that I can legitimately just take du and replace it with what it stands for. So coming down here, u, we said was 5 plus 2x cubed. So let's replace that u to the 1/2 power. Now, in this case, 6x squared dx, that is du. So you replace this with du, and you get the integral of u to the 1/2 power du. But don't forget, you're still multiplying it by that 1/6 on the outside to make sure that you're kind of taking into account the 6 that really wasn't there in the first place. So, now it's a basic integral. I will add a power to 1/2, so that's going to be 3/2, and divide it by that new power, which will be 2/3. So 1/6 times 2/3 u to the 3/2 power. Remember that plus c, alright, our constant of integration. And now it just comes down to replacing, alright, what we have been doing already in the past. So 1/6 times 2/3, that's going to simplify on down to 1/9. Replacing u, so 5 plus 2x cubed to the 3/2 power, and then our constant of integration, because it is not an exact evaluation there. Alright? Alright guys, on to the next one.